AI philosophy, enabling humans to establish destiny for themselves and establish a mind for AI. Einstein's Relativity of Space Time, hailed as the father of modern physics, completely transformed humanity's understanding of time, space, and matter. Einstein was a staunch determinist. He rejected randomness and indeterminacy in quantum mechanics, holding that God does not play dice. He opposed Kant's transcendental idealism, arguing that the fundamental concepts of scientific theories are not innate. His theory of relativity also contradicts Kant's view of absolute space and time. Click the plus sign to follow this account for more fascinating content. Albert Einstein, 14 March 1879, 18 April 1955, was one of the greatest theoretical physicists of the 20th century and is known as the father of modern physics. His major scientific achievements lie in relativity. See section 6.3, preliminary knowledge 3, mainstream scientific understanding of time and space, special and general relativity, and quantum theory. His contributions revolutionized the human comprehension of time, space, and matter. Einstein firmly believed that the universe operates according to some ultimate, knowable, and predictable set of laws. In his later years, he strove for a theory of everything that could unify all cosmic phenomena, attempting to bring gravitation and electromagnetism under one theoretical framework, yet he did not succeed. His key scientific achievements are listed below. Special relativity. In 1905, Einstein published Times on the electrodynamics of moving bodies, Times, and put forward special relativity. It established the relativity of time and space, and overturned Newtonian mechanics' notion of absolute time and absolute space. The theory states that physical laws are identical in all inertial reference frames. The speed of light in a vacuum is constant, independent of the observer's state of motion. It also introduced the concepts such as time dilation and the length contraction. General Relativity. In 1915, Einstein published General Relativity. See section 6.3.1. Differences between special relativity and general relativity. Gravitation, he argued, is not a force in the traditional sense, but arises from the curvature of space-time caused by matter. General relativity successfully explained the anomalous precession of Mercury's perihelion and predicted the bending of light in strong gravitational fields, which was confirmed by solar eclipse observations in 1919. Quantum theory and the photoelectric effect. In 1905, Einstein proposed the light quantum hypothesis and gave a successful account of the photoelectric effect. He suggested that light consists of energy quanta, photons, whose energy is proportional to light frequency. This work greatly advanced quantum mechanics and earned Einstein the Nobel Prize in Physics in 1921. Mass-energy equivalence. The equation E equals mc2 reveals the equivalence between mass and the energy E, showing that mass and energy can be converted into one another. It laid the theoretical foundation for nuclear energy development. Statistical physics and thermodynamics. Einstein also made major contributions in these fields. For example, he developed the theory of Brownian motion, providing evidence for the existence of molecular motion. Cosmology. He introduced the cosmological principle and boosted the development of modern astronomy. Furthermore, he predicted black holes and gravitational waves, predictions later corroborated by research. Presented below are Einstein's philosophical ideas containing profound reflections on science, religion, free will, and the nature of nature. 1. Pursuit of unity. Einstein firmly believed in the unity of nature. He held that all fundamental interactions and physical phenomena can be described within a unified theoretical framework. This idea of unity permeates both his scientific work, for instance, the creation of special and general relativity, and his philosophical thinking. He regarded the search for harmony and unity in nature as the highest goal of scientific inquiry. 2. Aesthetic and simplicity of science. Einstein maintained that the most elegant scientific theories tend to be the simplest. Science aims to interpret complex physical phenomena through the most concise mathematical structures and physical concepts. A theory ought to possess logical simplicity and self-consistency, embodying scientific beauty. This pursuit of simplicity was not merely aesthetic, but rational, for simplicity reflects nature's own essence. 3. Philosophical reflections on science. Einstein thought deeply about the nature and methodology of science. He emphasized the holistic character of theories. Components of a scientific theory are interconnected and cannot be viewed in isolation. He also argued that theory selection should be guided by simplicity and consistency rather than by experience alone. 4. Determinism and free will. Einstein was a convinced determinist. He resisted randomness and indeterminacy in quantum mechanics and famously stated, "God does not play dice," meaning the universe runs by strictly deterministic laws. To him, free will is a human illusion. The universe's future, just like its past, is preordained. This stance echoes Laplace's demon. Given the position and velocity of every particle in the universe, one could perfectly predict everything to come. Nevertheless, Advances in science have yielded abundant experimental evidence supporting quantum mechanical validity. See section 4.12. A probabilistic world. Uncertainty within certainty, certainty within uncertainty, necessity within chance, chance within necessity, which challenged and undermined Einstein's deterministic worldview. 5. Religion and the sense of mystery. Einstein held a distinctive attitude toward religion. He was neither a theist in the conventional sense nor an atheist. He leaned toward pantheism. See section 2.4.6. Deism, pantheism, and atheism, their differences. Treating the universe itself as something sacred, he had a keen awareness of the limits of human knowledge. Even with science's great achievements, cosmic complexity far exceeds human comprehension. A sense of awe for the universe and exploration of the unknown form common ground for science and religion. He once wrote, "The most beautiful experience we can have is the mysterious. It is the fundamental emotion which stands at the cradle of true art and true science." 6. Realism and separability. On foundational questions of physics, Einstein upheld realism and separability. He believed that a physical system possesses a real state independent of the observer, and spatial separation is a necessary condition for the individuation of physical systems. This position is especially visible in his critiques of quantum mechanics. 7. Rejection of Kant's transcendental idealism. Einstein opposed Kant's transcendental idealism. Scientific basic concepts, he contended, are not innate but freely created and stipulated by thought. No physical concept is inherently necessary or a priori correct. The right to exist of a concept depends solely on whether it bears a clear, unique, and unambiguous connection with physical events, experiments. Relativity demonstrated that space is Riemannian rather than Euclidean. Different distributions of matter and the energy curve, space, contrary to Kant's idea of time and space as an a priori absolute framework. In objects moving at high speed or in strong gravitational fields, time dilates and space curves, contradicting Kant's absolute space and time view. Critique of positivist empiricism. Einstein valued deductive reasoning and questioned induction. Scientific theories, he argued, do not emerge purely from empirical data. For example, the principle of the constancy of the speed of light in special relativity was not simply induced from observations. It contained hypothetical elements and was derived through rational deduction. Experience offers hints at the starting point of science, but does not legitimately validate theories. Empirical facts can test theories, yet are not the sole criterion. Newtonian physics, for instance, was confirmed by centuries of experience, but is not absolutely true, and was later revised by relativity and other new theories. I am Wu Huaiyu, a PhD from the Chinese Academy of Sciences, and a postdoctoral fellow from Peking University, and the founder of AI philosophy. For more detailed information, please refer to the complete version of this book. In addition to this short video, you can also click on my avatar to view more long videos.